Quadratics. They come from a function where your highest exponent is a 2. So these will all have x squared. Okay. We saw a lot of it last week and the week before when we were factoring our x box and our slip and slides. There were 3 pieces to it. Okay. There was an x squared, an x, and then just a number. That's called standard form. Okay. So we're going to have ax squared plus bx plus c. Okay. In standard form, each piece of the function gives you a different piece of the graph. Okay. I'm going to scroll down to this page. There we go. Okay. A parabola can open up or it can open down. It depends on if you have the function. If your ax squared, if it's a positive, it's going to smile at you. If your ax squared is a negative, it's going to be sad. It's going to frown at you. Okay. So if we're given the equation, we got to look at that very first piece to see if it's smiling or frowning. Okay. Something else the equation gives me is the y-intercept. It always comes from the plus c on the end. So in the example down below, we have x squared minus 4x plus 5. This plus 5 is where it's crossing over the y-axis. Okay, so that part's always given to you. Okay. The axis of symmetry and the vertex, they go together. The axis of symmetry is a line that cuts our parabola in half. The vertex is that turning point at the very bottom or at the very top of our parabola. Okay. To find axis of symmetry, we're going to do x equals opposite b over 2a, and that comes from the function. So if I have the graph out, I don't need to do all this math. If I don't have the graph, we got to do some math. Okay. It's not too hard, though. You'll be okay. That gives you the line that cuts it through, and it gives you the first part of my vertex, and then we just plug it in to find the y part. What's up? Yes. Yep. I say opposite b, so like if it's a, we'll get there.
What's the thing between that A and the S?
Oh, of axis of symmetry, AOS. Wow. So let's do the easy ones where the graph is already there and we can just like look at it and pick out our information, okay? And then we're gonna look at the function and plot our points and make the picture along the way. There we go, up here. Parabolas have a turning point that changes direction going up and down, okay? The left and right though goes forever, always. So our domain will always have an x as low as negative infinity and as high as positive infinity, meaning it's going forever both ways. It's never going to stop moving left and right. Okay? That's true for every single parabola. Every single domain will be all real numbers from negative to positive infinity. Okay? The range, that's our y values. So this is what Friday helped us with. A range is my y values. Okay? How low or how high can my y values go? This parabola has a turning point down here. What is that? 1, 2, 3, 4, 5, 6, 7, 8. That's -9. Okay. So are all of the other y's, are they going to be greater than or less than that -9? Greater than. Yeah. So all of my y's have to be bigger than or equal to the -9. We good? Okay. Our x-intercepts. They come from where our parabola is going to cross over the x-axis. So that's right here, and that is right there. So what is that? That looks like, I'll zoom in, -1, and then 2, 3, 4, 5, 6, and -7. So -1 and -7. Like that. So an x-intercept is when my y is 0. That shows it's on the x-axis. All right, how about the y-intercept? What? 7. I think so. 1, 2, 3, 4, 5, 6. Yes, 7. So we're going to write it as 0, 7. Okay, that's all old news. Okay, that's like level 1 key features. Do we have any questions about those guys? before we get into kindness and new stuff. Okay, come on. Stand up if you need to. Increasing and decreasing intervals. Okay? Every parabola has one of each. Half of it's going down, half of it's going up. Right? Does that make sense? If I draw the letter U, I go down and then up with my finger, correct? If it's upside down, I'm going to go up and then down. You're always going to have one of each. Okay? As we walk across, okay? See how we're going to fall down first? And then we stop at this turning point, and then we go back up again. So this parabola has an interval of decrease first, and then an interval of increase. Okay? Where does that change? Where does that direction change? It's at the vertex, but it's not the -9. It's going to be, what is that? 2, 3. It's going to happen at -4. Okay? When you walk, like in life, when you walk across, right? Left to right. We're not walking up the wall. We're walking on the floor, okay? So as I'm walking on the floor, I'm going to be falling down. That shows the interval of decrease. So from the beginning, -infinity, to an x value of -4, my y's are getting smaller. They're getting more negative, okay? And then as I continue to walk across from -4 to forever, if I walk along my parabola, my y values are increasing. They're getting bigger. Does that make sense? So increase, decrease, as I walk across, where am I falling down and where am I climbing up? All right, in behavior is nice. We always have a left side and a right side. So as my x's go negative, as my x's go positive, parabolas are good because they're either both going up or both going down. So this one, what are they doing? They're both going, they're both going up. So how do we say up with symbols? What did I use for my x's over there?
Oh, positive.
Yep. So for up, we're going to use infinity. So my x. Yep, if it was down, we would say -infinity. Yep. Good. All right. Here we go. Last two pieces. We've been using them. We just haven't labeled them yet. The axis of symmetry is what's cutting this parabola in half. Where is that happening? At -4, yeah. Ooh, come back. There we go. And is that an x or is that a y? That is where, yeah, x is -4. That's the equation of the line that's cutting through.
Can it be a y too?
Nope, it'll always only be an x. If it was a y equals and it cut across the y-axis, it would be a horizontal line, and that wouldn't cut your parabola in half. All right, my vertex. We've been using it. It's this guy, this turning point. It has an x of -4 and a y of -9. So your axis of symmetry is always the x value of your vertex. All right. All right, let's go down. I told you number 2. I'm going to go down to number 3 so you can see an example of one upside down. Okay, so you're going to do 2, but I'm going to do 3. So this one's all you. All right, number 3. Domain, what is it? We already know. Yes, negative to positive infinity. You can go ahead and put that to all your domains. They're all the same. All right, my range comes from my vertex. So it looks like we have a spot right here. Let me zoom in so I can count. 1, 2, 3, 4, 5, 6, 7, 8. It looks like a positive 9 this time. Bless you. So are all of my y's going to be above or below that positive 9? No, they're all below. Yeah, so less than or equal to. Thank you. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, 9. I know it's really small. It is 9. This is number 3. Yep. Yeah, this is number 3. It's okay. All right, x-intercepts. We got 2 of them. Looks like one of them is at -1. What's the other one? At +5. All right, we can easily pull out our y-intercept. Where is it? This guy right here. What is that? 1, 2, 3, 4. Looks like it's a 5. So 0 and 5.
No, this time I read it all as a
This is all number 3.
First I wrote it under the 2, then I wrote it in the wrong back.
Oh. We good? Any questions? Those are your basic key features. Now we get more in the nitty-gritty of quadratics. Woohoo! All right, increase and decrease intervals. So it looks like this one. So we're going to go from -infinity to something, and then that something to infinity, right? That halfway point, where is that? Looks like it's a 2. Yeah? So from -infinity up to the x value of 2, and I'm walking across that first half, am I climbing up or falling down? We're going up. Good. So that's an increase. From the very beginning until I reach that 2, we're climbing up. And then as I move past the 2, we're falling down. So from 2 to infinity, we are now decreasing in our y values. So up and then down. All right. In behavior, we have a left side and a right side. What are both of my ends doing? They're gapping. So how do we say that? They're going towards -infinity. Good. Okay. Axis of symmetry. What was that line that we used to cut it in half? 2. Is it an x or a y? It's an x. X equals 2. Good. That's the line cut in half, which we know is the first part of my vertex. What's the other part of my vertex? 9. There we go. All right, so you're going to use 3 to help you with number 2. I'm going to say look at number 3. And number 4, if you need help here, I'm going to say look at number 1. Because number 1 was positive and so is number 4. So those will help you the most. Yes, ma'am.
Next question.
Not yet.
Okay. Oh, I thought we were done.
Nope. We got 2 more.
Okay.
Yep, we got to do the back. We're going to do 5 and 7 on the back. I like to plot points as I find them, so I would have your other worksheet right next to you. All right. We're not going to go in exact order like we did last time because different things give me different stuff to help me find other pieces. So let's remember some key things we said earlier. This is standard form, ax squared plus bx plus c, right? We said a positive ax squared opened up. We said a negative ax squared opened down. What else did we say? Oh, axis of symmetry. We used doing x equals opposite b over 2a. Okay. Oh, we also said that this guy is our y-intercept. All right. There's a couple of things we can pick out of the function before we start having to break apart the function itself. Okay. What do we know about domain? There you go. It's always negative to positive infinity. Okay. I can't do range yet. I need my vertex first. So I can't do that just yet. X-intercepts, not yet. Ooh, but my y-intercept. I can pull that out of my function. What's my y-intercept? Yes, say it louder. 5. Yes, 0, 5. Good. I would go ahead and mark that on my graph. 1, 2, 3, 4, 5. So we have the point 0, 5 right now. That's our y-intercept. Okay. We're going to plot our vertex soon. We're going to have both x-intercepts. And then we got some extra spaces if we want to plot extra points. But those are our 4 main ones that you'll always plot. All right, so we have my y-intercept. Let's go back up here. All right, can I tell if it opens up or down? Yeah, it's going to open up. Good, because it's a positive x squared. So we know it's going to open up. It's going to definitely look like that. Increase, decrease. I know it's decreasing first, right? And increasing last, but I don't know where that turning point's happening. Does that make sense? I know we're going to start off decreasing and we're going to finish increasing, but I don't know where that turning point is happening at. We need my vertex. Can I do in behavior? Yeah, if I know it's opening up, then guess what both sides are doing? They're also both going up. All right, so we can get all of that just from the equation itself before we start doing any like real algebra to it. Okay, we really need my vertex. Okay, so to get my vertex, we start with the axis of symmetry. We get that x value that cuts it in half. Okay, so for my axis of symmetry, we're going to use x equals opposite b divided by 2a. I'm going to zoom in for you. A, B, and C. What is our B value right now? Right now it's -6, right? So what's opposite of that? +6. And then 2 times, what's my A value? It's a +1, yes. So that becomes 6/2, which is, what's 6 divided by 2? 3. So 3 is my x. That's the line cutting it in half. It's also the first part of my vertex. All right, how do you think we can get the y? If I have my x, let's plug it in to find the y. So instead of x squared, we're going to say 3 squared minus 6 times 3, and then plus 5. So plug in the x to get the y. That gives me 9 minus 18 plus 5. What is that? -4. 9 minus 18 is -9 plus 5 is -4. So there's my y. I'm going to go ahead and plot that point also. I'll come back up. 3, 3, -4. I will. Hold on. 3, -4 is my vertex. 1, 2, 3, and then down. 1, 2, 3, 4. There's my vertex. All right, and here's the y-intercept. So we need my 2 x-intercepts, right? To finish my graph at least. All right, I'll go back up for y'all. All right, we can use this to help me with my range and my increasing and decreasing intervals. Okay, my range, do I care about the x of 3 or the y of -4? For my range, I care about my y's, right? So y's are something with -4. Are they all bigger or less than? If it's opening up, they're all on top of it. Not sure about x-intercepts yet. Let's go to increase and decrease. Where did that increase and decrease change? I'm walking across. We're going to worry about my x value, which was at 3. So as I started at negative infinity and I walked across, I was falling down until I hit an x value of 3, and then I kept walking over, and now I'm going up. Okay. Last little bit, x-intercepts. This is where last week comes in. We have to factor. That's what factoring is. Factoring is finding your x-intercepts. Today, it's just going to be x box. Okay? Because we have 3 pieces. My x value is a 1, right? So let's go, okay, x squared minus 6x plus 5. We have more space down here. X squared minus 6x plus 5. Let's factor it. What multiplies to give me 5, but adds to give me negative 6? Almost. They have to multiply to give me 5 this time. I know, it's sneaky. What multiplies to give you 5? Just 1 and 5, right? So how can I add those to get a negative 6? Oop, negative, I can't, right? Negative 1 and negative 5. Is negative 1 times negative 5 positive 5? Negative 1 minus 5, negative 6. Okay, so we have factors of x minus 1, and we have a factor of x minus 5. If I want to know where it crosses the x, I need the x by itself. So I got one small extra step I'm going to do now. Because would it make sense for me to say negative 1 and negative 5? Does this make sense? 1, 2, 3, 4, 5. Does that make sense? Look at where my vertex is. That does not make sense. My vertex should be in the middle. Okay? Those are not my x-intercepts. But if I get x by itself by, in this case, adding 1 over, right here, and then over here, if I add my 5 over, now the x is by itself, and it shows you where it crosses the x-axis. 2, 3, 4, 5. And now that makes way more sense. So 1 and 5. Those are your x-intercepts. And now I can draw it. That orange dot on the side, by the way, it's an extra point. You don't need it. It's just the mirror image of the y-intercept. I noticed that it was 3 to the left of the middle, so I just went 3 to the right to give a mirror image. You don't have to do that. It's just a bonus point. Those 4 are the main ones that we need. You could plug in points to get more out, but those 4 are the ones that you have to plot. Any questions? That was a lot. It was a lot. What's that? I will with number 7. I will do it again. Okay. All right, here we go. Last one with me. We're going to do number 7. Number 7 and number 8, if you look at their functions, they both have something else happening to the x squared. So that's why I want to do number 7. What's in front of your number 8? There's a negative x squared, right? So is your number 8 going to open up or down? Your number 8's going to open down. No, you're right. When you go to get your x-intercepts, what should you take out first? The negative. Take the negative out. Okay? That's my little helpful hint for you on number 8. Okay. First things first with number 7. I don't have to look at the equation to know my domain. It's going to be what? There you go. Yep, negative cos infinity. I heard someone over here say it's going to open up. We know that because it's a positive 2x squared. You remember, you can go ahead and say this is down. We just talked about it because you're negative. All right, I can pull out my y-intercept. Where's that going to be? 24. Remember, that's the C value. Yeah, so 0, 24. Let me fill this in from earlier. All right, I can do in behavior, right? If I know it's opening up, then I know the left side and the right side are both going to positive infinity if we're opening up. Okay, that's all the stuff we can get before we start pulling things apart. Do you want to factor to get your x-intercepts, or do you want to get the vertex to get the range and the intervals?
Do the x-intercepts.
X-intercepts first? Sounds good. Yep, no, we're good. I'm going to do it down below. 2x squared, because I know I'm going to need the room. All right. It is 2x squared. Is it minus 16? Minus 16x plus 24. Okay. Yep, we're going to Xbox this one. First, I'm going to take out the GCF of 2 to get x squared minus 8x plus 12. All right, so what multiplies to give us 12 but adds to give me negative 8? What do you think? Multiply for 12, add to give you negative 8. Okay, what kind of a 6 and what kind of a 2? There you go, both negative. Does that mean my x-intercepts are at negative 6 and negative 2? No. That's my factored form. Remember, to get x by itself, you got to move it out. So we're going to have positive 6. Right, that's an x-intercept. We already have our y-intercept. And my other one is going to be x minus 2. So we get x equals positive 2. So 2. Because we're counting so high, do you want to change how our graph is counting? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You want to go by, go by 4s? Is that okay? I think 2s aren't going to be enough. 2s will get me to 20. I need at least 24, right? Yes, are y'all with me? Do you know why I'm doing what I'm doing? Because it's going to go off the grid? Okay, let's go by 4. 4, 8, 12, 16, 20, 24. There we go. And then 4, 8. I need 2 and 6. They're going to be right in the middle. 2 and 6. Okay. So y-intercept and then my x-intercepts. It's little, but it's there. All right, ready to get our vertex? Well, you can kind of guess what it's going to be if it has to be in between 2 and 6. What do you think it's probably going to be? Probably 4 something? I feel like it's going to be 4 something. Let's see. Let's go back up here. Okay. So 2 and 6. All right, let's find our axis of symmetry. Axis of symmetry comes from x equals opposite b over 2a. What's my b value? It's negative 16, so what's opposite of negative 16? Positive 16. 2 times a is going to be 2 times. What's my a? A is 2. That's going to be 16 divided by 4, so we get 4. Isn't that what we thought it was going to be? We predicted the future. We're magical. Oh, sorry. Thank you. I sat outside during lunch today. I think the trees are getting me. Okay, so we know the first part of my vertex. How do I find the other part? How do I use my x to find my y? Plug it in. Y equals 2 times 4 squared minus 16 times 4 plus 24. Let's do some order of operations. What comes first? Please excuse my dear Aunt Sally. Parentheses first, right? Well, there's just 4. I can't do anything with that. Excuse, so my exponents, do I have that? Yep, that's 4 squared. So that's going to be 16. My dear is multiply and divide. So that gives me, what, 32 right here. This gives me negative 64. And Aunt Sally tells me to add and subtract. So 32 minus 64 plus 24. I think it's negative 8. Mohammed, can you check? You're good at this. 32 minus 64, which is negative 32 plus 24. I think it's negative 8. Yeah, okay. There we go. I'm double checking this. Yes? Okay, good. The mind's a scary place. Thank you for checking. All right, we got my pieces. Now it's going to help me with my range. This guy is opening up, right? Like this. So are all of my y's on top of or below the negative 8? They are on top of the negative 8. Yep, let me graph it. 4, wrong one. 4, negative 8 was the vertex. 4, 8, look at that. Just like we thought it was going to be. Tall and skinny. Just like Muhammad. Not like Miss Dad was. You can laugh. No laughing today. The 2 out front is what's making this parabola stretch up. Okay, so all of my y's are greater than that negative 8. There we go. Now we want the increase and decrease intervals. So we know we go negative infinity to positive infinity. What's this middle spot? Look at your vertex. What is it, Gavin? What's that middle spot? Which one of those? Which one of those do I want to use? The 4. We good? Because remember, we're walking across. So when I walk across from negative infinity to 4, am I falling down or going up? We're falling down, right? So that's my decrease. And then as I keep going from 4 to forever, now we're climbing up the hill. Like that. All right? Yes. Well, it's 4 to positive infinity, if that's what you're asking. This one is positive. I'll do better. There you go. Yes, thank you for waiting. All right, so you are doing the evens. We will check them tomorrow. Work on them now. You got a little time. What's up? Yes.